Okay, Peter here in what I call Studio A, and today this is Studio A here, what I call affectionately Studio A, which is my downstairs radio room. Today we're going to talk about the Class E transmitter. I built this Class E transmitter, Class Echo transmitter, quite a few years ago, maybe 10 years ago, and I thought maybe we might talk about it today. And to anybody who may be interested in building one, I'll go over a couple things and kind of show you what it's all about. There are basically three components to the Class E transmitter. The first one is the RF deck, as pictured here. Second component is the modulator power supply, which is here. And then the third component is the VFO. The VFO, let's kind of start there. The VFO is there's a Hartley oscillator, and then it feeds a Hartley oscillator feeds a square wave generator, which splits it into two phases, and then we feed the RF deck with two phases. So I made the I made the VFO with PC board. If I was to do it over again, and I may at some point, I would make that instead out of sheet aluminum with a lot of screws, or possibly a cast aluminum. So, but it did come out pretty good there. That's the square wave circuit area there. So, and you can see the two coaxes going out and heading over to the RF deck. So, and let's look at the RF deck next. I got these microphones on the way. We'll see if we can work around them. So, the RF deck is composed of the big components you see here. This is the big coil. There's actually two coils there. There's one underneath it. That's the 160 band coil. This is a dual band RF deck. Top one is the 160 band coil, and then underneath it, if you can see it, I did bring a pretty good flashlight. You can see the 75 meter coil underneath it. So that is the main tuning capacitor there, which in this case is about a 15 kV vacuum variable, and above that is the additional tuning capacitor that I added for 160 meters. This is the loading capacitor here. If I can get it on there, all right. So that's the loading cap there. You can see the controls here in front here. So metering on the RF deck is composed of, move that out of the way, is the lower two meters are ammeters. They monitor the drain currents of each phase of the RF deck. In this case there are 6 MOSFETs each side on each phase. So we can give it a quick transmit here. You can see. Well, there you go. So over here in this area is the some of the power supply that I use, and also for metering connections, so forth, so on. So that power supply is mostly for some of the electronics on the RF deck, and so forth, so on. So now the RF deck, I built the RF deck. Really, I built it around a heatsink. So the first thing I found was a heatsink, and then so what you do is there's a lot of drilling and tapping. So you drill and tap all your grounds, all your MOSFETs, and if I can do this without shaking too much, get in a little closer here. You can see the buses, some of the buses in there for for this side. So you can also see, if you look down there, you can also see the I've got an Anderson connector I use to feed the modulated DC into the RF deck. That came in real handy, and I'll talk about that in a little bit. So so that's pretty much it. You can see the RF capacitors, high current RF capacitors, and these black things are relays. And these were Russian doorknob caps here. There's a better way to do it these days. They have these ATC capacitors. You can check with Steve's website, WA1QAX. He's the guy who designed all this. So I basically implemented and put it together into a working transmitter. So there you go. This is the RF deck. Basically, I think I mentioned it's 1/8" aluminum sheet is what really it's composed of, and then I used 1/8" angle, and I drilled and tapped the angle so it's all connected that way with stainless screws. I actually got the idea years and years ago from Brent, W1IA. He built his that way, and I liked the idea, and that's what I did here too. I think that's like about a 6U faceplate, something like that. So it just happened to work out. I think I got it for free from HR Electronics, if I recall correctly. They had it hanging around for a number of years. And this is the RF deck here. The RF deck this is the modulator. And the modulator is a pulse width modulator, and so I'll tell you a little bit about the components. These are some of the controls. Really don't use the controls very often. The potentiometers very often. Once you set it up, really it isn't that big of a deal. So and so it's pretty self-explanatory that way. Some of the components in here. This is the audio. This is an audio board here. Let me see if we can go grab a flashlight again. Oh, there's the audio board there. Pretty straightforward. This is a board you can buy from Steve. So this other board here. This is the pulse width modulator board here. And again, you can buy that from Steve. You buy the board, and I think he can supply you with a board. I don't think he supplies you with the components, but maybe he does. I'm not sure these days. Check his website, classetransmitter.com, I think it is. This is what he calls his efficiency board right here, which basically really actually is the controls for controlling the transmitter in terms of safety and so forth, so on. Overcurrent, or so it senses overcurrent, over voltage, and you've got potentiometer settings there to set up the transmitter. So I have a couple of relays in there. I have a push torque relay here, which is just a simple octal relay. Then I get a heavier relay here. So the small relay is kind of sequentially fires up the much larger relay here. So really not a lot to it. There's a capacitor bank there, if you can see it, for the power supply. It basically creates like 120 volts DC that feeds into the pulse width modulator, and this is the filtering in here. That's with all these orange drops. So for the filtering for the pulse width modulator, so it ends up delivering I think like around 36 volts DC and in audio on the feed into the RF deck. So that's the transformer. I did put the transformer on a separate. That's the transformer for the power supply on a separate chassis. So there you go. That is the story. In terms of the chassis for the modulator and also for the RF deck, I used what they call knockdown aluminum chassis, which worked out very well. So, and let's see, we could probably even turn a radio up. Maybe even oh, by the way, here's the watt meter. Maybe we can also fire things up. So let's get down here and hit transmit. Running about 250 watts. This is N1 PS testing. N1 power supply testing. Hello, test 1, 2, 3, 4. Hello, test. There you go. There is the Class C transmitter station.